two charged spheres are separated by 2 millimeter. Which of the following would yield the greatest attractive force? So here they asked attractive force, which means that it should be between positive and negative opposite charges. So here the combination is this one. So this is the right answer. The cylindrical capacitor is placed near another positively charged conductor. What is the net charge occurred by the cylindrical conductor? So here the charging by induction method, you should understand there will be no transfer of electrons. No transfer of electrons. So it should be 0. A comb run through one's dry hair attracts small bits of paper. This is due to the atoms in the paper get polarized by the charged comb. This is the answer. Here, when we are rubbing comb on our hair, it gets charged. And then paper is a neutral material, it is an insulator. And when the charged comb is near to this neutral paper is polarized. So it will be attracted towards comb. Charge on a body is integral multiple of plus or minus E. That is, Q equals plus or minus NE. It is implying the law of quantization of charge. This is the answer. When 10 power 19 electrons are removed from a neutral metal plate, the electric charge on it is. So when you are removing the electrons, the charge will become positive. But how much charge? To calculate that, we have to use Q equals NE formula. So N is 10 power 19. The charge of one electron is 1.6 into 10 power minus 19. So this will go away. We'll have 1.6 coulomb and it is positive. This is the answer. A body has a charge of a minus 2 microcoulomb. If it has 2.5 into 10 power 13 protons, how many electrons are there in the body? We have to find out that. So total charge on the body is actually due to the total charge produced by electrons plus the total charge due to protons. And total charge due to electrons can be written as number of electrons times the charge of one electron. The charge of one electron is E, but it is opposite charged, so negative E. Plus the number of protons times the charge of the proton is also E. So the charge of the proton and electron, they are same, but they are oppositely charged. We have to find out this quantity Ne, and this is given as minus 2 microcoulomb. So let's plug in all the values. So we can write the unknown quantity on the left hand side and then bring everything to the other side, Q minus NPE. This can be written as Ne equals Q minus of Q minus NPE divided by E. So it's NPE minus Q divided by E, that's equals 3.75 into 10 power 13. So this is the answer. There are 4 charges at the corners of the square, and we have to find out the force on the charge at the center O. So here, force on the charge. So let us see the electric field at this point. Suppose we have a positive Q charge here. And now let's see the force acting on this positive Q due to charge at A. So it's also a positive charge, so it should act this way. And now the force due to this plus Q due to at this point is actually on this direction, because that's also a repulsive force. So these two are equal and opposite, so they get cancel each other. And now the force on this point Q due to the charge at B, that is plus 2Q. This is also plus, so it will be acting towards this direction. And now the force on the charge at O due to minus 2Q, it's attractive force, so it will also act in this direction. So which means the net force is acting towards D. So it is acting along the diagonal BD. This should be the answer. There are 4 charged particles at the corner of the square, and there's an electron kept at the center of the square. Now we have to find out which direction the electron will move. So at the center, electron is there. So let's find out the charge. Alpha particle is positively charged, beta is minus, proton is plus, and then once again here plus. So due to the alpha particle, due to the plus charge, this is going to actually act this way because it is an attractive one. And then the force acting on the electron due to the alpha particle here, this will attract in this direction. So these two are equal and opposite, so they cancel each other. And now the beta particle will repel this way because it is an electron, and here it's also a negatively charged particle. And proton is positively charged, so it will attract electron. So the net charge is net force is acting towards D. So the answer is it will move toward D. The electric field required to keep a water drop of mass m just to remain suspended when charged with 1 electron. So we have to find out the electric field required for just suspend a water drop. This is a water drop. When you want to suspend something like that, the weight of the drop should be balanced by the force due to the electron, that is the electrostatic force. It should act in the opposite direction and it should be equal. So the electrostatic force is E times the electric field E, and the weight of the water drop is m times g. M is the mass of the water drop given. So we have to find E equals mg by E. So this is the answer. A charge of magnitude 3e and mass 2m is moving in an electric field. Now we have to find out the acceleration of the charge. So to find out the acceleration, we are going to use F equals ma formula. So from there we can write A equals F by m. The force acting on this is electrostatic force, and that can be written as Q times E divided by m. So what is the charge here? It is 3e, and the electric field is E. The mass is 2m. So it's 3e by 2m, and this is the answer. A charged particle of mass m, charge q, is placed initially at rest in the uniform electric field and then released. And it gains kinetic energy and started to move. And at distance y, what is the kinetic energy we have to find out. So we know the work done by the electrostatic force is used to move the charge in the electric field, that is the force work done by the electrostatic force times the displacement y. So the electrostatic force is charge times the electric field E times y. This is the displacement. So QEY is the answer. A charged particle of mass m and charge q initially at rest and are released in an electric field E. Now we have to find out the kinetic energy in terms of time. So let's do that. Kinetic energy equals half mv squared. Now we have to find out what is v. V is the final velocity. We can use the equations of motion. V equals u plus at. Initially it is at rest, so u equals 0. The acceleration is force per unit mass, and then time t. The force acting on the charged particle is the force due to the electric field, so it is q times E divided by mass m and then time t. Now we have to plug in this here. It is half m q squared E squared divided by m squared t. 1m will go away. We can write this as E squared q squared t squared here divided by 2m. So answer is B. Thank you.